Welcome to your second set of notes. This is for Unit 1, Notes B. We're going to focus on some foundational calculations. Today we're going to go over something called scientific notation. We're going to learn all about significant figures, and we're going to do some dimensional analysis. So first, let's look at scientific notation. There's a very special format that is valid for scientific notation. First, there is a number before the x. This number must be a value in between 1 and 9. You would never want a 0 or a double-digit number in front of the decimal place. You can, however, have as many numbers as you want after the decimal place. So we're looking at integers between 1 and 9, but with as many decimals as you want. Then you would use the x, like the multiplication symbol, and then the number 10, and then that 10 will have an exponent. Now that exponent can either be positive or negative. If it's a positive exponent like this one, that means it's a very big number. If it's a negative exponent, that means it's a very small number, meaning a decimal in real life. So this is our basic format. Let's look at some examples. The first thing that I want to do is pick out the integer that would go before the x. So for our first example, that would be the 3. Then I'm going to use the x and write the number 10. And then I need to figure out what the exponent is. So what the exponent does is it tells you how many numbers you've had to move the decimal place from. And that can be a little tricky. For example, in this case, there really is no written decimal. What you would always assume in that case is that it is at the end of the number. And then we need to move it all the way up to be behind the 3 where it is in scientific notation. So how many places are we moving it? 1, 2, 3, 4, 5, 6, 7, 8. So our exponent would be an 8. A positive 8 since this was a big number. You're also going to include units whenever you have them, in this case meters per second. Get in the habit of including your unit with your number at all times. Now let's look at the next example. Here we have two different numbers that are not 0, so this one might seem a little bit more complicated. Remember that the integer is supposed to be a number between 1 and 9. So would we make our integer 1 or 1007? Only 1 is between 1 and 9. So I'm going to put the 1 in front of the decimal and then put the 007 after the decimal. Then I'm going to write the x, and then I'm going to write the number 10. Just proper formatting. The next hard part is figuring out the exponent. Just like last time, we would assume that the decimal is at the end. So the question is, where did we move it? Did we move it behind the 7 or did we move it behind the 1? We moved it behind the 1. So how many places did we move that decimal? We moved it 9 places, so the exponent is a 9. Next question, should this be a positive 9 or a negative 9? Last question on this example, what are we forgetting? Yep, always include your units. Let's see if you can do this last one by yourself. If I look at my non-zero numbers, I see the 4, the 7, and the 6. I want to keep the integer between 1 and 9, so I'm going to use 4.76. I'm going to multiply by the 10, and then we have the exponent we need to figure out. In this case, we do have the decimal given, and we moved it all the way to behind the 4. So how many places did we move it? That would be 12 places. What makes this one different than the other two is we started with a very small number, a number that's a decimal. So we're going to use a negative 12 as our exponent. And then last but not least, of course, don't forget your unit. Did you remember the unit when you wrote your answer? The trickiest part about using scientific notation is actually using it in your calculator. So the first thing that I need you to do in your calculator is find the correct button. Usually that button is a double E, Some of the more simple calculators will say EXP. So for example, if you're using an off-brand calculator, it's usually EXP. The Casio calculators, I think, are the ones that do this a lot, the blue and white ones. They'll say times 10 with a little x exponent or times 10 with the little n exponent. Be careful. It is not the times 10 button or the 10x button, sorry, that's by the logarithm button. That is not the same thing. It's not going to do all three of the functions at once, and it's not going to be as good for order of operations. So you really want to find one of these three buttons. If you can't find it, take a picture of your calculator and send it to me, and I can circle it on your screenshot and send it back to you. You need to find these buttons. So now let me walk through how you would type in this example. You would type 5.02, and then you would hit your EE button or EXP button or whichever of those buttons, and then you would only type in the -3. So what that button really does is it represents the X, the 10, and the caret, for lack of a better term, or the fact that the thing that follows is the exponent. So that's one whole button, one of these buttons. So you're only going to type in the 5.02 and then the -3. Now the negative sign people have a hard time with too a lot. It is not the subtraction sign. It's probably in parentheses on your calculator. If you hit the subtraction sign, you're going to get a syntax error. Once I load that much into the calculator, I like to hit enter before I go on to hit times and finish the rest of the problem. It doesn't really do anything other than like save the order of operations of that being one number. It's just a habit that I found works better, especially with calculators that are particularly bad at order of operations. So take it or leave it. You type the 5.02 E -3 in. And by the way, on the calculator display, it'll probably only be one E no matter which of these buttons you're using. And then you're going to hit multiply. You may need parentheses. You may not if you've got a good EE calculator. But try it both ways. And then you're going to type in your 6.3369 E5. Do not hit an extra time sign. Do not type the 10. Just E5. And then you should be getting this number that's close to 3,000. Depending on the type of calculator, how you have it set to round, you may be seeing some of these other versions, but you want to make sure that you get about 3,000. So you want to pause it here. You want to try this over and over again in your calculator until you're able to get the correct order of operations with the correct button on your calculator. This is definitely something I can help you with on Zoom. The next thing that we're going to talk about is something called significant figures. This is what's behind where to round. That's why when we were doing calculations before, I didn't really get into where to round or why things are rounded differently, because you really have to understand what rounding is all about in science. It's not just always one specific decimal places. Like you may have a class where you always round to the 10th place. You're not going to have things like that in science. You're going to have meaning behind the rounding. So we call that significant figures. Basically, we want to round in a way that gets rid of numbers that are simply placeholders and only preserves the numbers that actually matter, that maybe were actually measured in order to be able to express what actually happened in a lab or experiment. The trick is only numbers that were actually measured are reliable. So we can only be precise as the tool that we are using. We can't take a ruler that only goes to the 10th place and make a measurement that goes to the 1000th place. Estimations are not reliable. After saying that, this is going to seem a little counterintuitive, but picture trying to measure something with a ruler. You can tell if it hits the mark exactly or if it's halfway in between marks. That's something that you can see with your eyes, right? So when we report a number, we are going to report one decimal place past what we can measure. Usually that number is reported as a 0 or 5, showing that it was like exactly on the mark or halfway down to the other mark. We want to try to be as precise as possible, which you might remember precision has to do with the exactness of a value. So we want to report, okay, it's dead on the mark or it's halfway to the next mark, because we can see that with our eye. But could we actually see that it's maybe 5.1 or 5.2? there's no markings to guide us in that, right? So scientists indicate the precision when they measure digits. These are significant figures. And the more digits, the more precise. So 3.50 would be more precise than 3.5. You've just got to keep in mind that this ties back to the tool. I can tell that the tool used to measure 3.50 grams was capable of measuring to the tenths place because we were able to estimate the hundredths place. I can tell that the value of 3.5 had ones place markings as opposed to tenths place markings. So it's going to have one estimated number, but that estimated number is not going to be anything super precise either. It's just going to be like dead on or halfway down. I know that seems a little confusing. It's something that we'll practice in the labs. The main takeaway right now is that the numbers that are here are actually measured. Now that you have an idea of what significant figures are, we're going to go over a rule to help you figure out how many significant figures a number actually has. There's a trick to this. It's called the Atlantic-Pacific rule. The Atlantic, as you know, is on this side over here on the right of the United States, whereas the Pacific is on this side over here by us on the left. So Pacific with the P would represent a decimal being present, which means we're going to come from the left side. If the decimal is absent with an A, we would come from the Atlantic side or the right. Once I know where to come from or start, then I'm going to count all the non-zero numbers until you reach the very end of the number. What this allows you to do is skip the placeholders. Let's check one out and see how that works. Here we have two different numbers. On the left, 3.00700, and on the right, the same digits, but now we have no decimal. So which one would be an example of decimal present? Of course, decimal present would be the one that physically has the decimal written. Decimal absent means we have that assumed decimal at the end, like when we use scientific notation. But as long as it's not actually written, we would consider that decimal absent. So if the decimal is present, that means I would start from the left of the number. And if the decimal is absent, like the Atlantic Ocean, I would start from the right of the number. Now, what does it mean to start from that number? What do I count? Let's look at our decimal present version. Coming from the left, the very first non-zero number that I hit is the 3. So it means I'm going to start counting at 3 and count to the end of the number, giving me 6 significant figures. With the example on the right, decimal absent, when I come from the right, the first non-zero number that I hit is the 7. So that means that I would count only 4 significant figures. The numbers that you skip are placeholders. Let's work a few more practice problems. I'll do the first 2 with you, and then you'll answer the next 4 on your own, then I'll go back over those answers. So starting with number 1. I do say a decimal, so I'm going to come from the Pacific side. The first non-zero number I reach is a 3. So I'm going to start counting at the 3 and count 1, 2, 3, 4, 5 significant figures. The zeros that I went through in the beginning are simply placeholders to put the 3 where it belongs. The 0 at the end here must have been measured. We must have had a tool capable enough to measure to this 5 on the dot. So that's 5 significant figures. On to number 2. Again, the decimal is present, so I'm going to come from the Pacific side. Then I'm going to drop down at the 3. I'm starting to count at the very beginning because that's where my first non-zero number is. And I'm going to count again all the way to the end, including the ending zeros, for again 5 significant figures. Next, you're going to answer what you think the answers, you're going to respond to what you think the answers are for the next 4, and then we'll go over them together. For number 3, again decimal present, start counting at the 7, all 5 are significant. For number 4, here we finally have one that has no decimal. So with the decimal absent, I'm going to come from the Atlantic, start counting at the 9, and I get 3 significant figures. For number 5, I have decimal absent, so I'm going to start counting at this 1, tricky 1 at the end there, meaning I count all 10 significant figures. And then for the last one, we do have a decimal, so back to starting from the left and counting all 3. These last two kind of show you that if you have all the zeros trapped in the middle, then of course they're significant. The only time you have non-significant or insignificant zeros is when they're placeholders, so like in the front of a decimal or in the end of a non-decimal. Now let's talk about how to round off a number. Later on, we're going to talk about how to know how many significant figures a result would be, like if you multiply two numbers together. So say your calculator gives you way more digits and you need to round it. How do you know when to round? So we're going to practice rounding all of these to 3 significant figures. Usually the first 3 numbers, starting from the left, would be included. Then you have to figure out, does the next number, only the next number matters, cause my last digit to round up? So in the case of this first example, or number 7, would the 2 make the 6 round up? You only round up if it's 5 or higher, just like in grade school. So that would just stay 366. And then don't forget your units. Let's try this next one because it's got a lot of place values. So the first 3 digits, the 904, are the numbers that I want to keep. And I want to make all the rest of these digits go away. But I still want to keep the place. I don't want to round this down to being 900 if it means 9 million. Would you rather $900 or $9 million? So we don't want to change the decimal place, for lack of a better term, or the place of the 9. So I want to turn these into placeholders. But you always want to check if your next digit affects the value you're rounding to. So in this case, does the 7 affect the 4? Yes, 7 is greater than 5, it will make it round up. So that becomes 905, but not 900, 9 million. So now we would have placeholder values, or placeholder zeros in milligrams. Another way to represent that, of course, is scientific notation, 9.05 times 10. Now, what would the exponent be for this one? Yes, 6, a positive 6 because it's large. And even with scientific notation, we got to make sure we include our units. Let me see if you can try number 9. What would 12.76 be if I had to round it to 3 significant figures? The 3 numbers we would keep would be the 1, 2, and the 7, except for the 6 would make the 7 round up. So it would be 12.8 grams. Number 10 is really tricky. How could we make that one have 3 significant figures? Any ideas? So here's our only answer. This one has to be in scientific notation in order to have 3 sig figs. Why? Well, we know it would round up to 1,000. And if we used the Atlantic Pacific rule on that, with no decimal, we would come through and only count the 1. That would have 1 significant figure. If I gave it a decimal, then I would come from the Pacific side. And yes, you can do that. You do not have to have a number after the decimal. You can end a number with the decimal to indicate the precision of the tool. So yes, we're coming from here and we're going to count our 1 and count 4 significant figures. So with or without a decimal, 1,000 is either 1 or 4 sig figs, not 3. So the only solution when that happens is scientific notation. Generally speaking, I'll take an answer in either scientific notation or long form like this. But if it has to have scientific notation because of sig figs, then you want to make sure that you do that. Now that you know how to round, we want to go over where to round. So our first rule for how to figure out where to round in calculations is that whenever you multiply or divide, you're going to limit your significant figures to the least number of significant figures. There will be a different rule for addition and subtraction. So as I go through and I multiply 3 numbers in this example, I count 1, 2, 3 significant figures for the 23.0, 1, 2, 3 significant figures for the 432, and only 2 significant figures for the 19. Of these 3 options, the 2 is my least number of significant figures. So although the calculator gives me 6 digits, I only want to take the first 2. So then does the 8 cause the first 8 to round up? Yes, it does. So I've got 1, 9, and then my placeholder zeros. You could also write this in scientific notation. You just want to make sure it has 2 significant figures because the least number of significant figures of all of your factors is 2. When you're adding and subtracting, the rule is a little bit different. It's still the least number, but this time it's the least number of decimal places. So to look at this example, our first factor, 0.25, has 2 decimal places. My next factor of 0.0 has 1 decimal place, and my next factor of 0.257 has 3 decimal places. So the least number of decimal places is just 1 decimal place. So from what the calculator gives us, that would be the 0.5. What it gives us would be the 0.5. So the 0, we want to make sure it doesn't make the 5 round up, and it doesn't, of course. So we just end with 255.5. Let's try some more practice problems. I'll go through the first one with you, and then you can try the rest by yourself. Actually, I'll go through the first 2 with you since we have 2 different operations. So the first one, 36.56 meters divided by 3.21 seconds. The calculator is going to give us 11.3925, and it just keeps going on. Since this is division, we're going to go by the least number of significant figures. We have 4 and 3. So the least number is 3 significant figures, which would be the 1, and the 3. We've got to look one past. Would the 9 make the 3 round up? Yes. So we're going to round that to 11.4. When we look at the units, I have a meter divided by a second. Those are 2 completely different things that do not cancel. So the meter will go on top and the second will go on the bottom, just like what happened with density when we had gram per cubic centimeter. Now let's look at number 2. With this one, we have addition as our operation. With addition, we go by decimal places. Our first factor has 3 decimal places, 3.3 only has 1 decimal place, and 42.9 only has 1 decimal place. So the least number of decimal places in this example is just 1 decimal place. So the calculator gives us 97.576, which we want to round to 1 decimal place. Would the 7 make the 5 round up? Yes. So this would be 97.6. When we add, the units must be the same for all of them, and they're going to be the same for the final answer. So the unit for this one is grams. Now I want you to try the next 3, and you will be marked right or wrong for the numerical answer for the next 3, and then as I go over them, I'll also discuss the units. So give those a shot on your paper as well. In number 13, we're multiplying, which means we're looking at the least number of significant figures. We have 3 sig figs first, followed by 4 sig figs. So the least number would be 3. So we're going to round our final answer to 3 significant figures, 76.2. When you multiply units, you square them, which is how you end up with cubic centimeters for volume. So the units for this one would be meters squared. The next one is all division. So for significant figures, we're going to go with the least number of sig figs. So we've got 3 sig figs divided by 3 sig figs, but then that's divided by 2 sig figs. So 2 sig figs overall would be the least number of sig figs. So 1.0 would be the correct answer with the correct number of sig figs. The units, however, are a little bit tricky. Let's look at this as if it's just the units. I have a meter divided by a second in parentheses, and then that entire thing is divided by another second. The only way to get a fraction out of a fraction is to use a trick called the reciprocal. So I'm going to put seconds over 1 because putting something over 1 doesn't change it at all. And then to get it out of the denominator, I'm going to use the reciprocal or flip it, which means I'll put 1 over s instead. Now as I multiply this across, on top I end up with only the meter, and on bottom I have seconds squared. So this is meters per second squared for the unit for the number 14. And then finally, number 15, since it's multiplication, I'm going to use the least number of significant figures, which would just be the 6. So you get in the calculator 56. You only want the first number, so the 6 will make the 5 round up to this 6, but it is 60. That 5 is in the tenths place, so when it rounds up to a 6, it needs to stay in the tenths place. If that makes you uncomfortable, you can always use scientific notation. And then the unit, volt times nothing, would just be volt. So that's it for your final answer. There will be a lot of mathematical calculations in this class, and from now on we will always want to round our correct answers to the correct number of significant figures. Finally, onto a process called dimensional analysis. This is the process that we use to convert one unit to a different unit. So for example, we wanted to convert 60 minutes into how many hours, we would need some kind of conversion process. We're going to use a series of what we call conversion factors. They basically look like fractions. These conversion factors should have two different units, but those measurements must be equal. So, for example, you could use 60 minutes and set that equal to 1 hour, but you would never say 60 minutes is equal to 2 hours. So 60 minutes over 1 hour would be a valid conversion factor, but 60 minutes over 2 hours would not. The first step in dimensional analysis is to identify the given information. What is it that you're trying to convert out of? So if I was trying to figure out how to convert meters to millimeters, meters is what I'm coming out of, and so meters would be my given. The hard part is setting up your conversion factors. Sometimes I put my given over 1, since again you can put anything over 1, just to make sure that I know it goes in the numerator. Whatever I put in that spot will always automatically be what you put in the denominator of your first conversion factor. Then you put what you're trying to convert to on the top. You can link together multiple conversion factors. So if I had conversion factor of going to B and I wanted to go to C, I could then put C on the top, multiply that instead, and then I would cancel B and get into C. So you can set this up like a chain so that numerators always cancel with denominators except for what it is that you want your answer to be. Whatever's left uncanceled will always show in the final answer. Then there's the process of actually calculating. So we want to be careful about how we put this in the calculator. Anything in the numerator is always going to have a multiplication sign in front of it, and anything in the denominator should always have a division sign in front of it. Yes, you can calculate this out as two separate things and then divide it later, but usually people forget parentheses and have some problems with calculator and order of operations. So as I go through some examples, I'm going to tell you how I would put it in the calculator. And just like with any mathematical process, the last step is to recheck. You want to go through your conversion map and make sure that all the units that you want to cancel do cancel, and the thing that you want as your final answer is not canceled out. Does your answer make sense? Is it what you were looking for in the first place? Let's try our first example. With this example, I want to convert 6 feet into inches. So the first thing I want to do is identify my given, 6 feet. I'm going to go ahead and put that over 1 so I can keep it in the numerator. And then the very first thing I'm going to do is put whatever unit is in my given in the denominator of my first conversion factor. Now, what is it that I want to convert to? In this case, it's inches. So the numbers that I want to put into this conversion factor should be equal units. How many inches are in a foot? Well, there are 12 inches in 1 foot. So I'm going to use that as a conversion factor. Now my feet cancel, but my inches don't. So that means inches will be in my final answer. The next thing I want to do is actually do the math. In this case, they're both on top. So 6 times 12 is 72. So the answer is about 72 inches. There's one catch, and I know this is going to make you uncomfortable. The given in this case only has one significant figure. We're essentially multiplying by things that are equal to each other. It's like multiplying by 1, so it doesn't really affect your significant figures. So if I have one significant figure that I'm starting with, I can't end up with more significant figures. So I need to round this down to have only one significant figure. So the answer with proper sig figs is actually 70 inches. Let's look at another example. This time they're giving you both some conversion factors and the given. I want you to read through this and determine what is the given. What should I start with? What am I coming from? That would be the 6,000 bananas. I'm trying to convert 6,000 bananas into something else. 5 bananas being equal to 1 bundle is a conversion factor, and 10 bundles being equal to 3 boxes is a conversion factor. So that's what I'm going to use for my fractions as I work this problem. So I'm going to start with 6,000 bananas, which I'll use BA for that, over 1. And then whatever I use in my first conversion factor must go in the bottom, BA. So I'm trying to convert to boxes, but I don't have any conversion factors that connect bananas to boxes. So what do I have bananas equal to? Bundles. So let's put bundles on the top. But I know I don't want bundles, so I'm going to get rid of it by putting it in the bottom. What could I connect bundles to? In this case, boxes. I usually set up my units first so that I know the direction I'm going is worth something. Here I can see that my bananas cancel, my bundles cancel, and I'll end up with boxes, which is what I want. If I can't make that connection, then no matter what the numbers are, it doesn't matter. So once I know I have this map laid out, I'm going to go back and put in the numbers based on the conversion factors. So bundles to bananas, my first conversion factor was the first sentence. 5 bananas for 1 bundle. The second conversion factor is next, 10 bundles for 3 boxes, here in my second sentence. So now I have my map, my numbers, I'm ready to do the math. The way that I would put this in the calculator for the best order of operations, I would start with the 6,000, of course, 6,000 bananas, and then since 5 is in the bottom, I would use divided by 5. 6,000 divided by 5, and then I would hit enter. Then since the 3 is in the top, I would hit times 3 and hit enter, and then hit divided by 10 and hit enter. So I'm just typing them in from left to right using the multiplication sign in front of the numbers on the top and the division sign in front of the numbers on the bottom. Could you go across and do 6,000 times 3 divided by 50? Yes, but I just feel like people normally have problems with parentheses and things where they get the wrong answer when they do it that way. The way that I described, where you always use just multiplication and division, depending on whether it's the numerator and denominator, should always work. So it's up to you. Let's get this in the calculator and tell me how many boxes that is. So you should have gotten 360 on the calculator. My next question is, what would that be to the correct significant figure? The given was 6,000. So since 6,000 only has one significant figure, decimal absent coming from Atlantic, 1 sig fig, I also want my final answer to have one significant figure. So I only need the first digit, the 3, and the 6 makes the 3 round up. So to correct significant figures, we have 400 boxes. Now let's try one with some conversion factors that you're familiar with, but using multiple conversion factors. So I want you to try to convert 1 year to seconds. How many seconds are in 1 year? I'm warning you, I'm going to need to see work for this. So I know you can try to do it in the calculator on your own. I want you to try to use the format that we just went over. Put 1 year on the top, figure out conversion factors, set it up using the format. You are going to have to show your work for this stuff. So there were lots of choices of conversion factors you could have went with. You could have went through months, weeks, days, whatever you chose to go to first. You end up with about 30,000 seconds. No, not 30,000, 30 million seconds. It's a lot of seconds. The point here is that no matter which conversion factors you go through, as long as they're valid, you should get close to the right answer. And then when you apply significant figures, all of the small details, like whether you chose to include leap year or not, will all come out in the wash. Now I want to really step it up. Let's try one that has 2 units. We're going to convert 25 meters per second into miles per hour. And then, of course, we'll round for sig figs. So 25 meters per second, you usually see written with the slash mark. Well, that's confusing because it makes it seem like it's in the numerator when it's really supposed to be in the denominator. So I always want you to write it like that, where it's in the denominator. So that's going to represent that in 1 second, you would travel 25 meters. We can't handle 2 conversion factors, or I'm sorry, 2 units at once. So we're going to focus on them one at a time. So first, let's focus on the meters. I want to convert meters into miles. So I need a conversion factor, or a set of conversion factors, that converts meters to miles. So take a second and check out the conversion factor sheet and see if you can find a way to get there. This is just one of the possible options, but I want to walk through it. So if we put meter at the bottom, one thing we could do is convert to yards, which means we would then put yards in the denominator. Then we can convert yards to miles, and that's where I'm going to stop because that's what I wanted in the end. So I've got my meters that cancel, my yards that cancel, and my miles that I want. Now let's look at the seconds. So I still have seconds in the denominator when I want hours. Just like how you would put something in the denominator to cancel with something in the numerator, if I'm trying to cancel out something in the denominator, I would put it in the numerator. Now I've got to try to figure out how to get from seconds to hours. So I know I want something larger than a second, so let's use minutes. But I don't want minutes, so I'm going to get rid of minutes, which is in the denominator, so I'll put it in the numerator, and then put hours in the denominator. Now I can go back and fill in 60 seconds in 1 minute and 60 minutes in 1 hour. Now it's time to put all of this into the calculator. Remember to hit multiply in front of the numbers that are in the numerator and divide in front of the numbers that are in the denominator. Or just be really careful about order of operations. Let's get this in the calculator. What did you get? You should have gotten 55.935 miles per hour, or that many miles in 1 hour. Now let's round that number to have proper significant figures. Remember, the significant figures are based on the given, the 25 meters per second. So what's the answer with correct sig figs? So for 2 significant figures, the answer would become 56 miles per hour. Just a quick warning on the test, be very careful because miles and meters are very different. The abbreviation for meters is M, but for miles, you could use MI. This stair step might look familiar to you. It's a trick for being able to move the proper number of decimal places, but it would require you to remember which prefixes go on which stairs. It's kind of a complicated way to do things. So another way to do things would be by using dimensional analysis. So if you know the conversion factors, you could simply convert, for example, meters to kilometers just by using dimensional analysis, using what you're trying to convert from as your given, and then set up your conversion factors. That's the end of Unit 1 Notes B. The next notes that you're going to be looking for would be Note C, all about matter.